Well, now we're going to do an example, and I want you to think hard. You have to think hard to really understand this.
I agree. Focus.
Okay, we'll focus. So at what point on the circle is x squared plus y squared equal 1? At what point on this circle is the product x times y a maximum and also a minimum? And we're going to solve this using Lagrange multipliers. First of all, f of xy is x times y. G of xy, we're going to say, well, this is our constraint, so g of xy is x squared plus y squared minus 1. We turn this into a function. Well, del f is the partial of this with respect to x, which is just y times I, plus the partial of this with respect to y, which is just x times j. So there's our del f. Del g is 2xi plus 2yj. That's easy to see that. And so del f of xy is lambda times del g. In other words, yi plus xj is 2 lambda xi plus 2 lambda yj, right? Just multiplying lambda times our del g. Since the I and j components are equal, that means that this component, 2 lambda x, has to be equal to y, and x has to be equal to 2 lambda y. So solving this equation for lambda, we would get lambda equals y over 2x, and this one we get lambda equals x over 2y. And so y over 2x equals x over 2y, since the lambdas are equal to each other. And what I was able to do was, in allowing for this lambda, I was able to use that lambda, that Lagrange multiplier, and come up with this equation. From this, we get the fact that if you multiply it by 2x times 2y, you would get something like 4y squared equals 4x squared, or in other words, y squared equals x squared. If we substitute that into the equation of the circle, x squared plus y squared equals 1, and we're going to substitute for the y squared, although we could substitute for the x squared and come to the same conclusion, we get y squared plus x squared, so that's really going to be 2x squared minus 1 equals 0, and solving that for x, we get x equal to 1 over the square root of 2 and negative 1 over the square root of 2. When we substitute these values in for x, keep in mind x squared equals y squared, so x equals plus or minus the square root of y, or maybe I should say it this way, since I have my x's, y equals plus or minus the square root of x. I'm sorry, it's not plus or minus the square root of, it's just x. Y equals plus or minus x. And so if x is a half, or 1 over the square root of 2 rather, y would be the negative of 1 over the square root of 2. Or, if x equals 1 over the square root of 2, y could be positive 1 over the square root of 2. Or, x could be negative 1 over the square root of 2, and y could be positive 1 over the square root of 2. Or, x could be negative 1 over the square root of 2, and y could be negative 1 over the square root of 2. So the constrained maximum of x times y is 1/2, because I multiplied this by this, I got negative a half, this by this, I got 1/2, this by this, I got negative a half, this by this, I got positive a half. So they're found by evaluating f of xy equals x times y at the points noted above. There they are. Perhaps this picture will make it more clear. By the way, I defined the xy plane. There's going to be a purple graph here, so you'll be able to see it. Now, here's what we have. We have this function x times y, which is the rainbow colored piece. The lavender there is the xy plane, and the circle would be this unit circle here, radius 1, see it? And we're looking for a maximum value of x times y on that circle. And I hope the picture makes it clear that we have a maximum over here of 1/2 at the point when x equals negative a half and y equals negative a half. Then the value of the function xy, I'm sorry, I said negative a half, that's wrong. It's negative 1 over the square root of 2, and y is negative 1 over the square root of 2. We wind up with 1/2. on the z-axis, so about here, right? And if they're both positive, like down in here, then, well, same thing. We wind up with 1/2. And if x is positive 1 over the square root of 2, that's 0.7071, something like that, and y is negative that, then we'll get a maximal negative value of -1/2. And similarly, for x equals negative 1 over the square root of 2 and y equals positive 1 over the square root of 2, we'll get -1/2 there as well. Here's our picture a little bit better, because I'm showing that the max. So I drew the circle on the plane. My software doesn't allow me to do that, but I copied it and pasted it into something that would let me do that. So there's the circle on the plane, and here's the value of 1/2 when looks like this is the one where x and y are both positive 1 over the square root of 2. Here's 1/2, x and y are both negative 1 over the square root of 2. Down here you can't see it because it's below the line, but I put it in with a dotted line. The z value is -1/2 here and here, because in this case x is positive square root of 2 over 2, or 1 over the square root of 2, and here the y is, I hope it is, negative 1 over the square root of 2. So that's pretty good explanation, I think.
I agree.